Figure 1.5 and the components of historical explanation for geomorphic events. Introduction. When we gaze upon the diverse landscapes of our planet, from towering mountains to deep valleys and sandy beaches, we marvel at the complex processes that have shaped these features over millions of years. Figure 1.5 provides us with a valuable framework for understanding how these landforms evolved and how we can interpret them. Figure 1.5. The intersection of historical and modern explanations. Figure 1.5 illustrates the relationship between historical and modern explanations in interpreting geomorphic events, which are events that shape and change the Earth's surface. We can visualize this figure as a spectrum ranging from explanations that rely entirely on current geological processes, modern explanations, to those that depend on the study of ancient rocks and sediments, historical explanations. The upper left quadrant represents small, recent geomorphic events, such as the formation of a small river channel or a small landslide. These events can be primarily explained by the geological processes occurring today, such as river erosion or wind erosion. The lower right quadrant represents large, ancient geomorphic events, such as the formation of a mountain range or an ocean basin. These events require more complex historical explanations, where we need to study sedimentary rocks and fossils to understand the processes that occurred in the distant past. The middle zone represents medium-sized, intermediate-aged events that require a combination of both historical and modern explanations for a complete understanding. Components of historical explanation. Historical explanations of geomorphic events rely on a variety of tools and techniques, including study of sedimentary rocks. By analyzing the types of sedimentary rocks and their layers, we can determine the environments in which these rocks were deposited and estimate the chronological age of geological events. Study of fossils. Fossils are the remains of ancient organisms. By studying fossils, we can identify the types of organisms that lived in the area and estimate the age of the rocks containing these fossils. Analysis of tectonic movements. Tectonic movements are movements of the Earth's crust that result in the formation of mountains, valleys, and earthquakes. By studying the effects of these movements on rocks, we can understand the major changes that have occurred on the Earth's surface. Why do we need both types of explanations? One might wonder why we need both historical and modern explanations to understand geomorphic events. The answer lies in the complex nature of geological processes. Geological events do not occur in isolation, but interact with each other over time. For example, an earthquake might change the course of a river, leading to the formation of a new valley. To understand this change, we need to study the effects of the earthquake, historical explanation, as well as the current river processes, modern explanation. Practical example: the formation of the Nile Delta. To illustrate this further, let's consider the example of the formation of the Nile Delta. The Nile Delta is a classic example of the interaction between different geological processes. To explain the formation of this delta, we need modern explanations. Study the amount of sediment carried by the Nile River to the sea and how this sediment accumulates to form the delta. Historical explanations. Study the sedimentary rocks that make up the delta and analyze fossils to determine changes in sea level and climate during the delta's formation. Conclusion. Figure 1.5 provides us with a comprehensive view of how we interpret the changes that occur on the Earth's surface. By understanding the relationship between historical and modern explanations, we can appreciate the complexity and beauty of the natural landscapes that surround us. In conclusion, the study of geomorphology is an exciting journey to discover the secrets of our planet. By combining various tools and techniques, we can uncover the natural forces that have shaped our world over millions of years.